Question number 16. This has been set from current electricity. However, the inspiration has been drawn from experimental physics. So that's an area where one has to give sufficient amount of focus. All right, let's see. The galvanometer is there with a resistance of 20 ohm and 30 division on both sides. So the full swing from the mid would be 30, and it has figure of merit, thus many ampere per division. So from this, I can calculate the full scale deflection current, the current required so that the deflection would be maximum. And that's so simple that this many ampere per division multiplied by 30, that's going to be 0.15 ampere. So this much amount of current is required to deflect the galvanometer till the fullest. And we want this galvanometer to be converted into a voltmeter of range 15 volt. So I don't think so there is any challenge here. 15 would be 0.15 multiplied by the resistance, let's say. Resistance of the galvanometer is 20 plus the resistance to be added in series, which is R, and that R comes out to be 80 ohm. So the correct option for question number 16 stands out to be option number 3. Let's move to question number 17. Question number 17 from thermal expansion. So upon the experience of the number of questions and the variety of questions that we have seen so far, now one thing is very clear. Students need to focus with great attention regarding those topics which are post-gravitation. And you see, the questions are very straightforward and it really helps you to score in the examination. So be careful with this thing, and I've been repeating it. So I really want that you take on these suggestions and flourish in the examination hall. So here it says, a thermometer graduated according to a linear scale reads a value x naught when in contact with boiling water. So here 100 is A x naught plus or B, because it says that it's graduated linearly. So temperature is Ax plus B. That's a sort of mathematical assumption we make. When in contact with boiling water, it's x naught, that's fine. And when in contact with ice, it's x naught by 3. So here ice, that's 0, which is equal to A x naught by 3 plus of B. Fair enough. Now these two values, you can calculate the value of A and B because x naught is a known parameter here. You need to calculate the temperature of an object if this thermometer is in contact with an object that reads x naught by 2. So that is equal to A x naught by 2 plus B. There's no further concept apart from this. You put the value of A and B and you'll get that the temperature is 25 degree centigrade. So option number 4 comes out to be the correct option for this question. Let's move to the next question now. Question number 18. You can see there is a certain arrangement of battery and internal resistances, 1 volt, 2 volt, 3 volt and stuff like this. We need to calculate the potential difference between A and B. Now here, if I will be able to reduce this thing into a single EMF with their internal resistance, the job is going to be very easy. So now what we'll do is that if you use the concept of E1 by R1 plus E2 by R2 plus E3 by R3, so that's a very straightforward. E1 by R1 plus E2 by R2 plus E3 by R3 is going to be 6 by 1 by R1 plus 1 by R2 plus 1 by R3, that's 3, and that comes out to be 2 volt. So essentially this given circuit can be reduced in this given way. This is 5 ohm, this is 1 by 3 and 2 volt, and this is 10 ohm. And now you could see that the circuit is completely open. So the potential difference between this two terminal will stand out to be the same when you calculate the potential difference between these two. So 2 volt will be the potential difference between A and B. Therefore, option number 3 would be the correct option for question number 18. Time now, we move to question number 19.